Question number 11, sine square n over n. You need to check whether this nth term of the sequence converges or diverges. Applying the limit n approaches to infinity, sine square of n over n. We can directly do it like this, like we were doing it in the limits question, like limit, just break it into sine n over n and then sine of n, and this thing will give us 1. No, this thing will not give us 1. It will give us 1 only in case if we have limit n approaches to 0 here. Then this thing will be 1 here. And then we can then get some defined answer. But here you see in this limit, like you have to check it whether it is converges or diverges. You have to apply the limit n approaches to infinity. This case equals to 1 will not hold if we have n approaches to infinity here. So we need to follow some other way to just evaluate this limit. And the other way is the comparison method. And what is that comparison method? We know very well that 0, we know that sine of n, the domain and the range of the sine x on the graph is between 1 and minus 1. The domain of sine of x, sine wave, is between, its range. The range of the sine wave is between 1 and minus 1. It can be written as 0 is less or equals to sine of n is less or equals to 1. It can be written like this because it has the range between 1 and minus 1. So it can be written as 0 is less or equals to sine square of n is less or equals to 1. And we know here we have sine square of n over n here. So I need to write here 0 is less or equals to sine square of n over n, and also we'll divide it here. So it will be like this. So it becomes 0 is less or equals to sine square of n over n is less or equals to 1 over n. So if we apply the limit on this left hand side and on this right hand side, and if both the limits give us the same answer, then that answer will be the answer of this limit. That is basically the sandwich rule. So how we will do it? We know that the left hand side, if we apply the limit on the left hand side, limit n approaches to infinity, on 0 will give you the 0. It is obvious. If you apply the limit n approaches to infinity on 1 over n, this will give us 0. So you see, if applying on both the left and right, the limit answer is the same. It means we can write it like limit n approaches to infinity sine square of n over n. This will also give us 0 by using the sandwich rule and by comparing it with the functions like this. So it gave us some defined answer of the limit, so the sequence converges to 0. Question number 12. Let's do it on the page. 12 says 2n factorial, this is the sign of factorial, divided by n factorial square. It can be written as limit n approaches to infinity 2n factorial divided by n factorial square equals limit n approaches to infinity. Now you know that how to open the factorial. Just move the 1 units back, keep subtracting 1. It will be 2n into 2n minus 1 into 2n minus 2, and if we continue in this manner, we will get n plus 1 up till n factorial. Divided by, we know that this is the whole square, we can write it separately like this, n factorial into n factorial. One of the n factorial will be cancelled with this n factorial, and we will be left behind 2n into 2n minus 1 into 2n minus 2 up to n plus 1 like this. And here this n factorial can be opened as n into n minus 1 into n minus 2 into up to 1, up till we get the 1. We know that if we open the 7 factorial, it will be 7 into 6 into 5 into 4 into 3 into 2 into 1. At the end we will get the 1. So it is 1 here. This n can be cancelled with this n. We will be left behind 2 into 2n minus 1, 2n minus 2 up to n plus 1 divided by n minus 1 into n minus 2 like this. If I take 2 common from each of the bracket here, I will get how many 2's? I will get n times this 2. So it will become 2 raised to power n, and I will be left behind 1 minus 1 over n into 1 minus 2 over n up till 1 plus 1 over n like this. Divided by, I will get, and I am also taking n common as well. I am also taking n common. So if I take n also common with it, it will be 2 raised to power n into n, and the down I want to take common, I will get 1 minus 1 over n, this is up to 1. 1 minus 2 over n up to 1. This will be also cancelled. Now if I have to write the limits with them as well. If I apply the limit on this function, on this whole function, I will get, I know that all these 1 over n, 2 over n, 1 over n, 2 over n, 1 over n, these things will give us 0 in my answer. This thing. So 1 minus 0 will remain 1, and 1 time 1 will give us 1. So this thing is solved, but the problem is with this 2 raised to power n. And 2 raised to power infinity will give us answer undefined. So it means the sequence diverges in this question. Now move on to question number 13. That says we have to check 2 minus n square over 3 plus n square raised to power n. This equals limit n approaches to infinity 2 minus n square over 3 plus n square raised to power n equal limit n approaches to infinity. I have n square in the numerator and n square in the denominator as well. I can take it common for making the fraction like this, because you know that if we apply the infinity limit in it, it will become 0. So it is easier to solve these kinds. So just take n square common, and I will get 2 over n square minus 1 divided by n square common 3 over n square plus 1 and the whole power n like this. This will be cancelled. So I will get here limit n approaches to infinity 2 over n square minus 1 over 3 over n square plus 1 raised to power n. If I apply the limit here, this will be 0, this will be 0. So I will get limit, I will get minus 1 raised to power n limit n approaches to infinity here. And you know that this term will always give you plus minus 1 in your answer. This thing will always give us plus minus 1 in our answer. That is the direct limit formula. So it means, you see here that sometimes it can give you the answer plus 1 and sometimes it can give you the answer minus 1. So the limit is not unique here. Since the limit is not unique, the sequence diverges because the limit is not unique. Question number 14. ln n whole square divided by n. Limit n approaches to infinity ln n whole square divided by n. We can simply know that this is the property of ln. If it has some power, it can be taken down. So it will become limit n approaches to infinity 2 ln n over n like this. Now you can use the L'Hopital rule here. It will become limit n approaches to infinity 2 into 1 over n over 1. So it becomes limit n approaches to infinity 2 over n. So if we apply the limit here, we'll get 0 in our answer. So it means the sequence converges. To 0. So the sequence is convergent in question number 14. square root of n into square root n plus 1 minus square root of n. Limit n approaches to infinity, square root n into square root n plus 1 minus square root n. I will solve it by rationalizing it. And rationalization means you have to write the same function with the middle sign opposite and multiply it and divide with it. So it will become under root n plus 1 plus the middle sign will change to plus and it will become n plus 1, and same thing you have to divide it with. Now we get limit n approaches to infinity under root n. We know that this is the formula for a minus b into a plus b. This will give us a square minus b square. So we got here under root n plus 1 whole square minus under root n whole square divided by this denominator as it is. This will be cancelled because it is squaring the square root. So we will get limit n approaches to infinity under root n, and here we will get n plus 1 minus n. This will be cancelled. Divided by, I can take under root n common out of it. So it will become under root n, and what here I will be left behind 1 plus 1 over n plus 1 like this. So simply this thing can be cancelled and it became limit n approaches to infinity 1 over 1 plus 1 over n under root plus 1. If I apply the limit here, 1 over infinity will goes to 0. So it will become under root 1. So it will become under root 1 plus 1. So it became 1 by 2. So the sequence converges to 1 by 2 like this. Apply the limit in question number 16 and the term of the sequence. Limit n approaches to infinity. 5 raised to power n plus minus 1 raised to power n over 5 raised to power n plus 1 plus minus 1 raised to power n plus 1. This will be equals to, I can see that I have 5 raised to power n in the numerator and in the denominator as well. I can take it common. So it will become limit n approaches to infinity 5 raised to power n. What I will be left behind? 1 plus minus 1 raised to power n over 5 raised to power n divided by 5 raised to power n common. So only 5 will come here with this power 1. 5 plus minus 1 raised to power n plus 1 over 5 raised to power n like this. This will be cancelled. So I will be left behind limit n approaches to infinity 1 plus minus 1 raised to power n over 5 raised to power n divided by 5 plus minus 1 raised to power n plus 1 over 5 raised to power n. Now if I apply the limit here, it will become 1 over infinity, and you know that 1 over infinity will give you the answer 0, because if we apply the limit on this side, it will be either minus 1 or it will be either plus 1, and that thing over infinity will give you the 0. So this term goes to 0, this term goes to 0, so you will get only 1 over 5. So the sequence converges to 1 over 5. So this is the answer of question number 16.